Love math.
Higher derivatives.
Whatever that is.
Okay, how would I calculate?
I'm in your bed. That sounds
Not
nice.
that
We can delete it. We can be pressing those way down there.
I'll give you a function. You know how to calculate the first derivative? Yes?
We're just calculating the derivative of this one.
Good. I'm confident you can do that. What is the second derivative?
I'm sure you're gonna tell me.
6.
You don't, how do you feel a math calculation? Can you feel the power Kronk? I can feel it. Like, really?
I need a funny.
Zero.
The third derivative?
0.
Okay, who wants to keep putting tick marks on there?
No one.
Me.
Yeah, me either. So we write the rest of them with numbers.
Wait, so when it gets. Oh.
So
So it's just
first, second, third derivative, fourth, fifth, sixth, you write the actual number. Okay? So am I gonna need, do I need to go on?
Yes.
What's the highest you can go?
That one was. That was less than really has.
There's a little more to it than that.
If it was just this,
I bet you would be stoked.
I think I get a bunch more response.
Hey, Mr. Arthur, how far can you go?
What?
Infinite. Infinite. You can just keep putting, like, have the longest polynomial, and then just.
Well, I know, but can you go to like
Let's look at that, Kate.
5 of X?
This one never ends, right?
No.
No, well, that
What do I have to do to calculate this derivative?
Yeah.
That one
power
thing.
rule.
No, product rule. Because it's multiplication, it's a product. So,
So it's EX.
go, calculate it. You need to practice.
Okay, hold on. So
Remember.
copy.
Copy first,
Copy, derive.
or sorry,
Derive,
derivative
copy.
first,
Oh.
copy second,
Copy.
plus copy first, derivative second.
C, right?
Derive, copy, copy, derive.
Would you like to?
Oh, no, it's 2 copies.
E, C, C, D. That works.
Boom. We can use that here.
Times H.
That times H, oh, sorry.
Yep.
Yeah, that. First, I
The derivative, copy, copy, derivative, E, C, C, D. That's good, that works. I don't mind that. Okay, second derivative. Is this gonna get painful very quickly?
Yeah.
It already is.
Product,
Oh. Oh, man.
and
Wait,
it's the
no.
same, right?
Yeah.
Same product, so it's the same. So that here is this. All right?
Oh.
That's the derivative of that. Now what do you have to do?
The derivative of EX times 1. Nah. Nah.
Yeah, we can stop.
Thank you.
But you get the idea of using
So
the
that one
product
just go
rule
on
again and
forever.
again and again? What would a quotient rule look like?
Alonzo.
I'm not going to, but you gotta think about these things. Okay? Get your books. Get your books out.
If I flip to the page, you owe me $1. What page is it?
You don't flip to the page, you owe me $1.
No.
Well, Fair
There's
is
a lot,
fair.
there's a lot less of a chance of me actually picking
Right.
the page.
So why would you bet on such an odd?
Hey,
I'm not
done.
betting, I'm just wanting
Page
to
160.
Even you're trying to do.
No.
You're gonna owe me $1.
Oh, I did do it.
This
Holy
one.
No
crap.
way.
I just did it.
I win.
I should have
Hold
took
on,
that.
hold on.
Oh, dear God, did I just
160.
do that?
Dang.
Give me
Yeah.
that.
Look at this. Look at that. Look at that. No problem.
Yeah, if I flip to this page, I'm gonna be
It is not
You did do it first.
I did do it first try.
Yeah, you did this though. You went.
Okay.
Oh, that's 100.
Look at example 1.
I did not do that.
Quiet down, children. Example 1. Household energy use in Deutschland. Yeah. Just coincidence, honestly. Okay, here's the question. You're looking at a table now, right? What is happening to the derivative? Okay, what's happening to the function? Is it increasing?
Yes.
Every time it increases, correct? Okay, the derivative is decreasing. Why? If you look at the graph on the left, what's happening? The derivative is not going down, it's still increasing. Well, the derivative is decreasing, yes, because the slope is getting smaller,
So you like 3 of them?
okay?
Thank you.
What would the second derivative look like? You gotta look at the change in the slope value for the, if the first derivative is decreasing, right? The slopes are getting smaller,
Wouldn't it just be like,
the second derivative will be,
so if it's decreasing sharply,
Decreasing.
then wouldn't it be like decreasing at a less sharp rate until it got to 0? That's what's happening there. Is it
here's the graph of that table, right? So the function is increasing, correct? So F is increasing, so energy consumption is increasing. Look at the slopes of the tangent lines, they are decreasing, they're getting smaller. So F prime is decreasing. What would F double prime look like? These slope numbers are going down. So F double prime would be positive or negative? Negative.
So they just keep going down on that one?
So F double prime would actually be down here.
That means,
It's an F of I.
why does that happen?
If F prime is decreasing, that means that the slopes are getting smaller. You're subtracting out, right? So your second derivative is going to be negative. So let's let me give you some hypothetical.
I don't get it.
You know what the fourth derivative would be? Positive.
Okay, if this is, the derivative is decreasing, it's still positive, yes? Okay, so the derivative here, the graph of it is probably going to look something like this. Right? What is the change happening here? Down by a half, down by a fourth? Negative, right? The change in the first derivative is negative. Second derivative is negative.
So it just stays negative from there on out?
Right?
So that means
kind of, you're thinking about it in terms of what's happening. So you know how you say, well, f is decreasing, f prime is negative,
So what,
right? Because the slopes are going down, they're negative.
So-
It's the same concept with f prime is decreasing, f double prime is negative.
So f prime is, you determine those values by the slope of the original function, and f prime 2 you're just determining by the slope of f prime 1.
So, remember, if f is increasing, the derivatives are positive.
so even with
Right.
f of x,
What happens if f is increasing or decreasing? F prime is negative, right? It's the same relationship here. F prime is decreasing, f double prime is negative. It's just a different level. Okay?
so even for f of x equals x, the square root of x, it would be f
F
double
prime of x, yeah, f double prime is negative. Okay, graphically, it's concave down. See how it curves, the cave is downhill, downward? That means that the second derivative is negative. Okay, that's graphical.
So if you had a negative like the parent function, first derivative would still be positive, derivative would stay negative, the second derivative would be positive, so it would be flipped.
You say if we have a graph that looks like this,
If they have a parent graph that is below 0 on the y-axis.
it's not a position issue, it's a shape issue. The second derivative is negative because it's concave down,
Right.
or because the first derivative is getting smaller and smaller and smaller, decreasing. Okay? The first derivative is really big here, steep, from 0 and into the negatives. The first derivative is decreasing. That would make it second derivative negative. Should we have more time to do this?
So how should the derivatives be like?
Like this.
Yeah.
Okay. If this is f or f prime, this is f. Okay, the derivative is gonna look like that. Because it's decreasing.
So first it's increasing and then decreasing.
F is increasing,
Yeah.
then decreasing. F is increasing, the slopes are positive, so the positive numbers here. The slopes are negative, so negative numbers here.
What is decreasing?
Oh, this is first, sorry. Okay, the second derivative is negative slope. That right there.
Because it's,
It's a linear equation. And it's negative slope, right? So the values of f double prime will be negative. You get a handle on it.
Yeah.
Like after the test when you get a 1, right?
Yep.
That's all we have time for. Note that, you know, position. Okay, position. Velocity is s prime, right? Position, and then velocity is the derivative. What is the second derivative? Acceleration. If you see a word problem with acceleration in it, go to the second derivative, okay? That's too quick, but any questions? Tuesday, bring questions on Tuesday.
Oh, definitely will.
So you're gonna be calculating higher derivatives, you're gonna be drawing graphs, and you're gonna be using this. I just don't have time to show you the word problem I want to show you. 3.5. Prelim number 4. Here are the exercises. I was very picky here, obviously. 37. So, the exercises that look like a lot, but it's very picky. And then AP 213, and I'll let Josh work on the rest. You said that with such enthusiasm.
Enthusiasm is almost completely non-existent.
Yeah, I agree. You know, I'll be honest with you, Canyon, I'm in that boat right now. But when I get in here with you guys, it kind of changes things.
I was worried you were, I was worried you were already.
Same with
It's
you.
gone.
I don't want it to spiral. It was genuine, just accept it.
Although I hate chemistry class, and then I really think about it.
Yeah, she moved me away from Jason.
Oh, imagine that.
No, that's not why I hate chemistry. I
It's
hate
actually,
chemistry because she
that was
goes
pretty
to
bad.
the rest of
Now, the only way Jason stays awake is if he's moving around the classroom, or if he's like sleeping at the desk.
Or sitting by me.
Does anybody have a calculator in their possession?
Yeah.
And Mrs. Johnson.
We do not.
All right. Have a nice weekend, everybody.
I'm not sending you anything to check.
Oh, yeah, good.
Yes.
Yeah, I was gonna say, yesterday she was confused
I
about
want to go get a really nice,
That's right.
really safe recipe.
Just remember that if there's a fork in the number, it doesn't go all the way across.
Homecoming sponge.
Your one.
I don't know, I'm just really craving something chewy. That goes really
I
well.
love it.